Today we're talking about complex numbers and how they can be written a couple of different ways. Um, so far we talked about graphing points, both in the rectangular plane, so graphing x, y, meaning go horizontally a certain number of units and then go vertically a certain number of units. And then we talked about graphing in the polar plane, which is like face the angle and walk r units, whether that's forward or backwards. And so now we're going to look at complex numbers. So we talked about complex numbers back with quadratics, imaginary numbers, or combinations of real numbers and imaginary. And so we can graph complex numbers as well. So here's another um, axis or coordinate plane. It looks like the rectangular coordinate plane, but it is called the complex plane. So in the complex plane, the horizontal axis is the real number axis. So you can see it says R for like real. And the vertical axis is the imaginary number axis. So I for imaginary. Um, every complex number will be given as sort of in this form. We tend to call the complex number Z, and Z will be A plus BI. So we've seen that before. A is the real part, and BI is the imaginary part. So you can plot these just like you would plot a rectangular coordinate. So um, if I want to use this complex plane to graph these numbers, it's pretty simple. 4 is the real part, so I go right 4 units, and 2i is the imaginary part, so I go up 2 units on the imaginary scale, and this is where point A would be. So point B would be left 3, down 5. So it feels just like you're plotting a rectangular coordinate because we're back to having squares instead of concentric circles for our grid. If I don't have a real part, this is like 0 plus 2i. So point C would just be on the imaginary axis, 2i. And if I only have a real part, that's like 1 plus 0i. So that would just be 1 on the real axis. And this point, ignore that. That must be something that I clipped that I didn't include here. Okay, so plotting the points, not too bad. What we're mostly interested in, though, for our AP exam is how can we translate from a number that's maybe in complex form to writing it in its polar form or going the other way? Um, to be honest, I don't work with these complex numbers in their polar form all the time. I'm certain this is setting us up for something we would do in higher levels of calculus. If anyone knows, let me know. But we don't often use our complex numbers in polar form for Calc 1 or 2. But it's worth getting used to because it's using all the same stuff we've been working with. All right, so let's take a look at this imaginary axis. We've got some point, A plus BI, and we can create a right triangle out of this, just like we did with an XY coordinate. Now, the legs of this triangle would have a horizontal leg of A and a vertical leg with a distance of B, and we would have some sort of radius R. Theta, of course, is always the reference angle between the horizontal axis and the terminal side. So if I am trying to write a complex number in its polar form requires an r and a theta. So r is still calculated using Pythagorean theorem. R would equal the square root of a squared plus b squared. All right, well, what about a and b in their polar form? So remember, just like we had for x and y coordinates, because this is still rectangular, it's still true that the cosine of theta would equal a over r. So to find the a, which is kind of like the x coordinate, the horizontal distance for rectangular, that would equal r times cosine theta. And b is the vertical distance. So because sine theta is equal to b over r, then b would equal r sine theta. So that's the same rules that we had for rectangular coordinates. We're just swapping x and y for a and b. And theta could still be found using tangent. Theta would equal the inverse tangent of b over a. Although when I'm doing this, I usually just say tangent theta equals b over a, and then I work on this to figure out what the angle should be. All right, now we know that we can write a complex number as a plus bi. This is the rectangular form. So this is a complex number in its rectangular form. What would it look like in its polar form then? So polar form is saying, all right, instead of a, we have r cosine theta, and instead of b, we have r sine theta times I. And often we write this r factored out. So a lot of times for our AP exam, you'll see that a complex number can also be written as r times cosine theta plus sine theta times I. So cosine theta and sine theta will be coefficients. We will have those values. So write each complex number in its polar form. Right now it's in its rectangular form. So A is 4 and B is 2. So if I want to write it in its polar form, first I should find r. R is equal to the square root of 4 squared plus 2 squared. Square root of 20. We need to simplify for the AP exam. It's 2 radical 5. And then for the building the complex number, it's just z equals 2 radical 5. And then what does this formula say? It says cosine of theta. Well, what's theta? Let's see. Tangent of theta should equal b over a. All right, so what is theta when we get 1/2? This is not one of our nice answers for like a non-calculator problem. So when is tangent equal to 1/2? I'm going to use my calculator for this. So in my calculator, I want to make sure that I'm in radian mode, not degree mode, so radian mode. And remember, to get an angle, you're just saying second tangent of 1/2. Let's round this to 3 places. So we'll call this 0.464 radians. So theta is about equal to 0.464 radians. Now you don't have to write the word radians. I'm just reminding you that's what we're finding. All right, so the cosine of 0.464 plus the sine of 0.464 times I. Or you could write I times sine of 0.464, that's fine too. And we don't need to simplify this. If I were simplifying this, I would not use 0.464. But we don't have to simplify this because remember, cosine of 0.464 should equal 4, right? Let's check that. Cosine of this angle, times 2 radical 5 should equal 4. And sine of this unrounded angle theta multiplied by 2 radical 5 should equal 2, and it does. So you can check your work, but polar form, it seems weird. It seems like we're unsimplifying this, but polar form is just to write it like this. So basically, find r, find theta, write polar form. Okay, let's do the same thing here. So a is negative radical 3, b is 1. So find r first. The square root of, when you square a negative, it becomes positive. When you square radical 3, it becomes 3, plus 1 squared is 1. Square root of 4 is 2. Tangent of theta equals 1 over negative radical 3. This could be a non-calculator one. So when is tangent of theta equal to negative radical 3? Well, there are 2 angles that make that happen. So let's see. We've got the reference angle is pi over 6, and we're negative. So 5 pi over 6 or 11 pi over 6. Which one is it? Well, I think we could have I think we could go with 2 possible answers here, but let's plot the point to be sure. If I go negative radical 3 and up 1 I would be in quadrant 2. So I should probably pick the quadrant 2 angle and then keep r positive. So I'm going to say that z is equal to positive 2 times the cosine of 5 pi over 6 plus the sine of 5 pi over 6 times I. Could I write negative 2 times the cosine of 11 pi over 6 sine of 5 pi over 6? Let's see. I think so. No, wait, could I? Yeah, I could, because you would still get, so this comes out as 2 times, this comes out as 2 times negative radical 3 over 2. And if I did the other way, the cosine of 11 pi over 6 is positive, but then you're multiplying it by negative 2. So you would still get the same answer. So I think this is a possibility too. And then sine of 11 pi over 6 would come out negative, but you're multiplying it by negative 2. So I think that's okay. I think either one is acceptable. All right, what if we're going the other way? So these are the really easy problems. If we're going the other way, easy peasy. We're trying to get z equals a plus bi. All we have to do to get a and b is do the math. They've done the hard work for us. We just have to simplify this. So what is the cosine of 4 pi over 3? Cosine of pi over 3 is 1/2. 4 pi over 3 is in quadrant 3, so negative 1/2. What is the sine of 4 pi over 3? So the sine of 4 pi over 3 is equal to negative radical 3 over 2. And then distribute the 5 through. So 5 times negative 1/2 is negative 5/2. 5 times negative will be minus 5 radical 3 over 2 times I. Here is the rectangular form where we can clearly see what a plus bi is actually equal to. Same thing here. Let's see. Z is equal to, so we have, here the 1/2 has been distributed through. So we have 1/2 times the cosine of 3 pi over 4 is negative radical 2 over 2, plus 1/2 times the sine of 3 pi over 4, positive radical 2 over 2, and then I'm going to put the I out here. So z is equal to negative radical 2 over 4 plus radical 2 over 4 times I. All right, so that's it for complex numbers. Again, what is the point of writing complex numbers in their polar form? I'll be honest with you, at this moment, I do not know. That's something I need to go back and look at. But I do know that we have this in our AP Pre-Calc curriculum. So I don't know, maybe it's something with physics, or I always hear about electrical engineering with eyes. So we'll have to look into this some more.